we continue our discussion with automatic data capture using RFID and its applications. This in fact, to remind you, last class we discussed about this technology, and in this class we are going to look at few applications. To start with, we will be first seeing that how RFID is using for warehouse management. Secondly, we will see how RFID helps in supply chain management and what are the prospects. Again, we are going to discuss what are various concerns in adopting this RFID technology. First of all, if you remember, while discussing about warehouse management system, we were talking about various functions that a warehouse management system has to have. So, here specifically we are going to see for few functions how RFID is going to help. First, consider the case of receiving the items. So, when you receive the items, you have to check it against the electronic advance shipping notices which comes from your upstream supplier. So, in this environment, when the in a RFID enabled environment, when the items come, they come with RFID tags which contains the details of not only the item level details, but also the details of the SKUs and the packages in which they are placed. So, therefore, while receiving, instead of manual counting or counting using a technology like that of RFID reader, your barcode reader, where which is a line of sight technology, and you have to actually bring the barcode reader towards the barcode. So, then only it can read it. But in case the items are put in a RFID tags, even if they are put in one stock keeping unit, then along with the unit, without opening it, you can read all the details of the items that are placed inside it. So, therefore, while checking the items against the electronic advance shipping notices, not only the time decreases, but also it is very convenient. You really do not have to open the seal, yet you are able to read everything. Then comes the another function of a typical warehouse management system, that is put away. So, here when the items come in, to keep those packages in the right place, to identify which places in the warehouse, which aisles, which rack is free, and putting the items therein, depending on the size of the item, the decision regarding that can now be automated, because the item details come along with the RFID tag, and as we have discussed last class, this RFID tags contain the code, but the detailed information actually is there somewhere in the internet, in a server. So, here also in the warehouse the system will be able to read those details from the server with against the corresponding URL, and it can know the details of the item. Once it knows the detail of the item, which may include its dimension, etc., along with the data that is coming from the warehouse itself, where the locations are free, you can match, and accordingly you can decide which is the best storage location, so that you do not waste much of your storage. Then second is replenishment. Here if your shelves are RFID enabled and smart, as soon as your item level goes down, some trigger will be enabled and decisions can be taken by corresponding enterprise system. Then in big warehouses, picking the items, when the requests come for getting the items from the warehouse, picking the items from various locations in the warehouse is again a complex decision problem. This material handling equipments will be moving around the warehouse, and they will be picking the items. So, finding a proper schedule and deciding the path of those equipment around the warehouse can also be automated if the data can be captured automatically using RFID. Then next is sortation. Here once again the varieties, the item details like about their categories, geographical area, etc., are known from the details stored in the tags. So, once these details are known, some automatic procedure can be established for sortation. Similarly, when the items along with their packages with stock keeping units together, when they leave the warehouse, you do not need any manual intervention here for counting the items, etc. Once they leave the warehouse, at the door itself there can be some RFID reader which will read all the details about the items getting dispatched, and accordingly the advance shipping notices can be made and transmitted to the next supply chain member. Then of course, we have discussed so many times that stock counting is very easy in case of RFID. In case the items are misplaced that and still remain in the store, they can still be taken into consideration. So, the shrinkage which otherwise includes the items which are stolen or misplaced in the store, these shrinkage phenomena can now be reduced with the use of RFID. Then tracking of goods. When the goods are moving along the supply chain, they can be tracked by their batch number and other details. So, now let us see, just look at one illustrative example. This example has been taken from this particular paper, Chou's paper, and with this example the ideas that I was talking about can become very clear. Now, consider a RFID based enabled warehouse, and this is, let us say, this is a very simple warehouse layout plan. These are the aisles and their x and y coordinates are known, and within this aisle the stock keeping units will be placed, and this material handling equipments will be moving around. Their work will be either to keep it in a predefined position or pick up. So, during both receiving and picking up, these material handling equipments will be moving around, and once a schedule is provided to them, as per that schedule they will be picking the item or keeping the item. So, now in this particular setting, the problem is to calculate the travel distance. See, we are now associating a decision making problem with that of RFID. Now, see, RFID does what? RFID generates the RFID stores the data, and at the time of need you will be able to retrieve the data. But the keep storing the data and retrieving the data is not the solution to any business problem. There has to be some associated business decision which is best performed by using those data. So, now the problem here is to calculate the travel distance and the picking sequence for material handling model and construct the path for material handling equipment that minimize the total distance covered. Now, these SKUs which keep the stock are attached with SKUs, these stock keeping units which are attached with passive RFID tags, so also the items, and the readers are appropriately placed across the aisles. Look, to make it little more elaborate, the items will be kept in these stock keeping units anywhere. Let us say this is one item which is kept in this place in the aisle. Now, there has to be simply by tag, as you know the RFID technology, and as we know that in supply chain situation mostly the tags that we use are passive tags. These passive tags cannot emit information on their own. So, they need to be they need to be awakened by some nearby antenna which is attached to some reader. So, this reader antenna, once they come under the magnetic field of the reader antenna, they will be reflecting back the data that they have. So, therefore, around this place in right positions, the readers, the reader antennas need to be placed. Now, this reader antenna positions, when we decide the reader antenna positions, we have to keep many things in mind, so that they are placed in such, they are kept in such places the maximum coverage is occurred with minimum number of antennas, but anyway we are not going to discuss that problem. What we are going to look at is the antennas are already placed and all the aisles are covered by at least one antenna. So, therefore, whenever you have any stock keeping unit attached with a passive tag and it is under the antenna's field, then its position can be then its knowing the position again only with one antenna, it cannot be done. That is again another problem altogether. You need minimum 3 antennas to know the exact location of this, assuming that this is covered by at least 3 antennas, but of course, if you want only the data, not the position, then you can use one antenna is sufficient, but now we are talking it as a location problem as well. So, therefore, we assume that again it is covered by at least 3 antennas and their locations can be known from the system that we are the warehouse management system that we are talking about. Okay. So, SKUs are attached with passive RFID tags and readers are appropriately placed across the aisles. Now, forklifts attached with active RFID tags, these material handling equipments with forklifts and all, they are attached with active RFID tags. Now, while discussing about RFID, we were talking about this active RFID. Active RFIDs are basically used for asset tracking. They have their own batteries, they do not need any power of their from external sources like that of passive tags, and these RFIDs, these active RFIDs, they are also Wi-Fi enabled. Most of the time they are Wi-Fi enabled. So, through Wi-Fi also they can send their location. So, we now have the location data of the SKUs kept on the aisles and the location of the forklifts, that is your material handling equipment, which is to go and pick up that package. So, now when this RFID enabled forklifts, RFID tagged forklifts move around, they are supposed to be provided with a list of items to be picked up, because it is a large warehouse and for one item you should not be using it, it will not be cost effective if you send every time the forklift for picking one item. So, depending on your demand of which all forklifts need to be which all SKUs need to be removed, are required to be removed, their positions, for example, here let us say this is one, this is one, this is another and this is fourth one. These fourth black dots, black spots are for the SKUs which need to be removed. Now, when we decide a material handling equipment to be moving and picking these items up, what is the optimal path, so that we will be minimizing the total cost of travel. Now, in this area again you see there are two material handling, two forklifts are moving, two material handling equipments with forklifts are moving. Now, if the position, if the picking sequence are coming randomly, every time, let us say this particular forklift, every time it need not come back to the place where it has to take the list of the items to be to pick up, but it should also be advantageous if this particular if the driver of this forklift is able to know while moving that if a new request has come for pickup. So, if it is within its path, then and it is instructed where it is, then it can pick up. Now, the question is, there are two such material handling equipments are moving around here. So, which one will be used to pick up? So, natural answer is let us say we are trying to give this already has one order and a new order has come up, that is for this one. Now, it is very natural that we will be asking this the driver of this material handling equipment to pick up this one, not to the driver of this particular material handling equipment. So, therefore, as the pickup requests come in, we should be able to give instruction to this moving right the right material out of these two moving material handling equipments, we should be able to instruct to the right equipment to get that item. So, therefore, the problem is little bit now complex. So, these forklifts are attached to the active RFID tags, they keep moving, then now they are driven by human drivers who is provided with a touch screen to get the instructions on their picking sequence. So, as and when the new items, new requests come for picking on their screen, they will be automatically getting this. Now, it is a moving equipment, it is getting tracked by its RFID, it should be getting the instruction back from some decision support system on its screen. The driver should be able to get this instruction on its screen. So, therefore, the system, the warehouse management system should be remotely sending, maybe through Wi-Fi, it should be sending the data of the picking sequence to the right material handling equipment. Look, this is some examples where the pallets are attached with the RFID tags, even the RFID in the side of the dock door also the RFID tags are attached, and this is what I was talking about. The driver who is moving around the warehouse, he will be sitting on this material handling equipment, and he has a touch screen computer where the details of the picking sequence will be shown. Now, the data, see, we have two types of RFID tags. One is the passive RFID tags, which is attached to the pallets and stock keeping units, and we have some active tags which are attached to the material handling equipment. So, now the antennas collect the passive these pallets which and the items they are in, which are attached to the passive tag. Once they come under the field of the passive tag reader, they will be emitting the data details. So, also the details will be coming from dock doors, from forklifts and so on. They will also be having some readers. Here also there can be some antenna. So, now once all this data is collected about their positions, they will be sent to some data collection procedure. In fact, we talked about multi-tier architecture of RFID data collection already. So, we are not going to repeat it again. You can read the you can go through the earlier video about this. Now, this data across, this is the example that we were showing, and it is also Wi-Fi enabled, LAN is there, and antennas are accordingly positioned. So, these signals come from many directions and they are sent to appropriate resource tracking module. Their positions and details will be sent to the appropriate resource tracking module. Now, this module will have some front end. In fact, that front end will be, see, driver is the operates the material handling equipment, but in the warehouse itself, let us say in the place where the picking will be the actual picking delivery will be done, there will be somebody who may also have a screen. So, when we are talking about the front end module, it is about the front end of all the stakeholders who are involved in or interested in tracking the items and getting the related data. So, we have once the data comes in and it is processed with appropriate decision support for moving the vehicles, those details should also be shown on the computer screen of the respective stakeholders. Then in this particular example problem, which we have adopted a research paper that I have already told you, there is a resource management engine which has a case based reasoning. We really do not have to know much, but because we are not going to the analytical part of it. So, but we should be also know that RFID data, I have already told you, RFID data does not do anything on its own. It need to be processed and some analysis need to be done. So, at least let us try to understand that resource management engine does some kind of analysis. Analysis about, here our problem was for deciding the right picking sequence and sending that sequence to the right material handling equipment. So, for this purpose, the data that is coming from the location data that is coming from both passive tags attached to the SKUs, pallets and items, etc., and to the active tag which is attached to the material handling equipment, all of them, once the data comes in, then there has to be some decision support module. What the decision support module will do? Decision support module will be providing the optimal picking path. Now, this deciding about the optimal picking path, if some of you might be knowing that it will be a variation of a travelling salesperson problem. So, that there is no repetition of the path through which the items are the material handling equipment is moving to pick up the items, and also the capacity constraint of the material handling equipment should also be kept in mind, so that you do not provide a request to the driver to pick up more number of SKUs or the pallets which are beyond its own, beyond the capacity of the this picking vehicle. So, therefore, once this instruction is sent from this engine, it now goes into the it is now sent to the front end that we have already discussed. That front end is nothing but the computer screen which is attached to your material handling equipment, or it is the desktop of your other concerned stakeholders. Now, let us look at how RFID can automate the supply chain. So far we have been discussing that RFID is how RFID will be automating the warehouse, and within the warehouse you have material handling equipments moving and items kept. But this RFID doing this task within a warehouse is fairly possible, is quite possible, because you can actually place antennas around the warehouse. Now, when we move to a supply chain, the problem is bit different. Different in the sense, you cannot have these antennas once the items are out of the premises of the producer or the warehouse or whosoever where they are kept, and the items are on the road. Your RFID technology is not going to work, because it is, you do not have antennas, you cannot really have antennas all along the road. You use a different technology for that we are going to discuss. But assuming that you have all the supply chain members have RFID and have compatible technologies for RFID that they are using, how exactly the item will be tracked throughout the supply chain, and what are various ways of doing it, that we are going to look at in the next lecture. Thank you very much.